So we're doing 6.8, number 10 from Ready, Set, Go. And I sent you guys off to your groups already. And it says triangle ABC is an isosceles right triangle. The length of one side is given. Fill in the missing values and the missing sides and angles for A and B. So before I had you guys go, I said, I love this triangle. This is my friend 45, 45, 90 triangle. So lately I've been trying to show you guys how important your 45, 45, 90 and your 30, 60, 90 triangles are. So I sent you guys out and I said, okay, go find out from your group how I knew that this was a 45, 45, 90 triangle. So I got some responses back. And some people said it's because of these marks right here. And yes, that is one of the indicators that I knew that this was a 45, 45, 90 triangle. It also told me that this is a right triangle here, right here. So I should put that in there too. So it having being isosceles, that's what isosceles means, two sides congruent, or some definitions say at least two sides congruent. So the fact that it was an isosceles and right triangle, the only person that fits that criteria would be your 45, 45, 90 triangle. Okay. Some people said because of that root 2, and actually, no, that's not correct. This root 2 has nothing to do with the fact that this is a 45, 45, 90 triangle. But some of you are thinking, but Ms. Johnson, in a 45, 45, 90 triangle, you have a root 2. Yes, but you technically, this could be any number I want. That's why when I label it X, X, X root 2. So the biggest indicators for me that this is an isosceles right triangle, the biggest indicator for me that this is a 45, 45, 90 triangle was that they told me this is an isosceles right triangle. Okay, picture in and of itself, it was not it, because they didn't give you the fact that this is a right angle. So this right here told me that this was a 45, 45, 90 triangle. Very good. Some people, they kind of ignored the fact that it was a 45, 45, 90 triangle, and they were still able to find all the sides, but then maybe got stuck because they didn't know how to find the angles, right? Okay, these little tick marks here, some of you are trying to remember what that means. Whenever you see these little tick marks, it means this segment, AC, is congruent to this segment, BC. Oh, so that means that this is root 2 as well. Yes. Someone asked, Ms. Johnson, do the marks mean that, do the marks mean root 2? No. The marks mean that it's congruent. But Ms. Johnson, you wrote that it's root 2. Doesn't it mean? No. So one more time, I can draw you a triangle over here and say that these 3 sides are congruent, and I could put a 9 here. So if you say that this tick mark means root 2, then you think that this tick mark means root 2, and that's not correct. Okay. So then, because I know this is a 45, 45, 90 triangle, I put in here that this is 45 degrees. Over here, I'll put pi over 4. I'm still in betweener for those of you who have moved on to radians and those of you who haven't. So now I'm going to use my right triangle, my 45, 45, 90 skills. Now someone said, they explained it. They said the hypotenuse is x times radical 2. So we know that x is rad 2, so that would be rad 2 times rad 2, which is just 2. So I'm going to copy this and paste it into our notebook. It's not going to show up right away, but that's okay. Let me put it over here. It'll show up eventually. But right now, there it goes. I figured a faster way to get your chat in our notebook. Okay, so the hypotenuse is x times root 2. So this person is showing off like, hey, I remember my 45, 45, 90 triangle, and this is just how they did it. You set the legs equal to x, and then the hypotenuse is x root 2. Since this literally says x equals root 2, x equals root 2, I take this guy and I substitute him in here. So I get root 2 times root 2, equals root 4, which is just 2. So there you go. This is that. Now, if you didn't know how to do this problem, not a problem. Just go back and make sure that you can explain this problem to someone else. Okay. So we're moving on to our next problem. It says, each point on the circle marks the end of a terminal ray in standard position. Label the measure of an angle of rotation at each position on the terminal ray. So the terminal ray is just these guys. This is a terminal ray. Okay. So it's that guy. Oh, oops. Or this guy. It's any of the ones that are there. The angles will be in radians. Leave your answers in terms of pi. Okay, so some of you already know how to do this. There's a lot of lines here. If you can, try to ignore some of them so that it doesn't make it so busy. Okay, so right now you guys are going to go to your groups and you're going to, all you're going to do is, let's see, label the measures of the angles of rotation at each position. So how many, like, what is this? They don't want the coordinates. They just want the angles of rotation. Like, how much did this circle turn from here to here? Got it? Okay. So I'm going to pause the video and you guys are going to go. And then if you're watching the video, just come back and check your answers. Okay. So when we're doing this problem here, I already heard from the first group that came back how they solved this, but I want to hear from the rest of you. How did you do this problem? How did you find out this problem? What did you do? There were basically 2 steps, 1 step, 1 step, 2 steps. Yes, okay, so very good. So actually before that, before you even marked it in degrees, you had to do something. What did you do before you started marking? Yeah, so someone says, I know a whole circle is 360, so I divided that by 8 since it's 8 sections to get 45 degrees. Okay, so this is why I like radians better. So I'm going to say the same exact thing that this person said, except for I'm going to change it out for hold on a second. I'm going to change that out for radians. I'm trying to fix my formatting is a little bit off. Yeah, that's better. Okay. Instead of saying I know a whole 60 is 360, a whole circle is 360, I'm going to say a whole circle is 2 pi. Okay. So I divided that by 8. So I take 2 pi and I divide it by 8 and then I simplify. That's pi over 4. Okay. So someone said I found it in degrees and then I not translated it. Converted. That's what they said. And then I converted it. Right? So I converted first and then I did the same thing. So each of these sections is pi over 4. That's what I got. Very good. So someone else did, I did 360 divided by 4, the number of bigger sections, and divided that by 2. Exactly. Okay. So I'm going to tell you, I'm going to keep pushing you to go with radians. So when you go back and you start talking, if you catch yourself talking about degrees, stop yourself and be like, radians. So another way to do this too is I know that this is pi. Do you guys remember that? This is pi. This is 0. This is pi. How many sections are there in pi? 1, 2, 3, 4. I have 4 pieces of pie. Does everybody see 4 pieces of pie here? Can you ignore these guys right here? Just ignore them. Ignore those 2 lines. So does everyone see 4 pieces of pie or 4 pieces of pizza? Yeah, then that means this is pi over 4. Now, I'm going to bring you back to 2nd and 3rd grade where you all would choral count. Do you guys remember choral counting? You would count together. You would count objects together. This is how you got better at counting. I know, but all of you are what you call it? All of you are muted, so no one will hear you. Okay, so we're gonna count by pi over 4. Before, you used to count by um like fours or by twos. Okay, let's practice choral counting by twos. Ready? 2, 4, 6, 8, 10, and so on. So we're gonna choral count. No one's gonna hear you. Okay, we're gonna choral count. Except for now, we're gonna choral count pi over 4. Ready? Pi over 4. Here. 2 pi over 4. Next one. I don't know if you guys are talking. All right, I'm going to pretend you are. 3 pi over 4. And then the next one. 4 pi over 4. And some of you are like, Miss Johnson, doesn't 4 pi over 4 simplify to pi? Yes. Isn't that great that they're sitting right next to each other? Miss Johnson, do you want us to write 4 pi over 4, or do you want us to just simplify in our heads and put pi? For the beginning, I would like you to choral count exactly the way you're seeing it here, right? Because I need you to make those connections and see how to count. Okay, continuing on. 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi. I know you guys are thinking, oh my gosh, or something. I'm so glad that we're not in person because you would really make us choral count out loud. Heck yeah! Loud, so that other classes would hear you in a sing-songy voice. I'm just kidding. I wouldn't do that. I would just make you choral count. And then 8 pi over 4. Ta-da! We did it. Okay. And then I would go back through and I would simplify them. So yes, I would simplify u to pi over 2. And yes, I would simplify u to pi. And u to 3 pi over 2. And u to 2 pi. Yes, that is what I do. If you notice, it's every other one. And you can think to yourself, oh, that makes so much sense. And it does. Okay. Thank you for listening. And so whenever I'm labeling stuff, I always go based off this. Okay. I just want to talk about one thing before, because the bell just rang or is about to ring. There is no bell, but my alarm just went off telling me I have 5 minutes. Hurry up, Miss Johnson. This 3 pi over 4 business, this is how my brain thinks. Okay. So follow me on this. I pretend that this is a whole pie, which it is. Does everybody see my whole pie? So I'm going to go back and forth between PI and PIE. So I'm going to go back and forth between pie and pizza. Same picture in your head. So I have a full pie here. So can everyone imagine a full pizza box? Like you just got it delivered, it's full and it's cut up. Everybody see that? And they cut it up into 4 slices. Everybody imagining? Yes, Miss Johnson, I see my 4 slices. And then, I don't know, one of you come and eat one of my slices of pizza. I'm fine. I'm sharing. Who cares? So now how many slices of pie, pizza, how many slices of pizza do I now have? And you guys are like, 3. Good. 3 pi over 4. Does that make sense? All right. Now, for some reason, we're having a pizza party in our classroom, and I like to condense things. So I have a full pizza box. Does everybody see my full pizza box? It doesn't mean it's all the same. Like it could be like cheese and veggie. Like it's all there, right? Okay. And then I have one loner pizza sitting all by himself. How many slices of pizza do I now have? And you guys are like, 5. Good. 5 pi over 4. I have one more or one less off of my x-axis. Same thing goes here. I have one more. And then this one looks kind of weird. It's one less than 2 pizzas. So can everybody imagine we ordered 2 pizzas? How many slices do I have? And you're like, 8. Good. And one of you ate a slice. How many slices do I have? 7 pi over 4. So I really, really like this. I'm going to tell you again, this is like one of those little things that's going to make your understanding go a little bit more. And you're like, seriously, Miss Johnson, it's fractions. I know. But when I tell you stuff like this and I'm like, hey, I want you to find the sine of 5 pi over 4. You're like, oh, no problem. I got to draw it first, Miss Johnson. 5 pi over 4. So if this is 4, this is pi, then this is 4 slices of pie, right? Oh, I have an extra slice of pie. He's right here, right? Or pizza. Sorry, I should be saying pizza. And then, so we're going to talk about this a little bit more next time. So if you have questions for the rest of this, just make sure you ask.